we will be discussing about some circle theorems, theorems of circle. So in this chapter, according to our NCERT, we are having total 10 theorems. So we will be visiting each and every theorem one by one, how to prove it, its diagram plus its explanations. So friends, be ready with your compass, your pen, scale and protractor. So here comes our theorem 1. Theorem 1, 2, 3 and 4 I have proved in my previous live sessions. You can just revisit those live sessions and get to know about these, but I am explaining these theorems once again in this live session quickly and briefly. So we come at our theorem 1. There is a unique circle passing through three non-collinear points. So what does this mean? See, first I would like to tell you all that theorems of circles, in theorems of circles we are having many theorems. So for that you also need to know the construction of circles with the help of triangles. How can be done? How can it be done? There is a certain method of constructing. In NCERT, the first exercise, there is a question: draw triangle ABC with AB is equal to 5 centimeter, angle A is equal to 70 degree and angle B is equal to 60 degree. Draw the circumference of triangle ABC. Is the center inside or outside the triangle? So there is certain procedure of drawing the circle with the help of a triangle. So this is a bit long procedure, so I will not be touching this right now, but rather I will be teaching you this concept in the next live session. So till then, yes, as the theorem stated that there is a unique circle passing through three non-collinear points. We know that non-collinear points are those points which lie on a same straight line, but these points, point A, point B and point C, do not lie in a same straight line. They are randomly pointed and they form a triangle, and a triangle is always formed by three non-collinear points. So hence this theorem is true, and I will be making a separate video on it. Here comes our next theorem, which is equal chords of a circle subtend equal angles at the center of the circle. What does this theorem mean? First, I will be drawing a diagram. I'm so sorry, I was busy for a moment. So we have our theorem 2 and I would like to draw its diagram first. See, as I informed you in my previous live session, drawing a diagram is a must for your exam point of view. I'm drawing this circle with one hand, so it's a bit difficult. I have drawn this circle. Now the point where I kept my compass tip is this. This is point O and it is the center of the circle. So now what the theorem states: equal chords of a circle subtend equal angles at the center of the circle. So according to this theorem, we first need to make two chords. Chord AB, AB and chord DC. According to this theorem, these chords, here is it is written na, equal chords of a circle. So it means that chord AB is equal to chord DC. Then it is written that they subtend equal angles. What is the meaning of subtend? When a chord subtends an angle, then it looks something like this. Now we have two distinct triangles, triangle AOB and triangle DOC, and they are also equal as the theorem states. So see, whenever we get a question, either it is physics or chemistry, then we have to mention that what is given to us. What is given to us? AB is equal to DC and angle AOB angle AOB is equal to angle DOC. Angle DOC. This is given to us. What we need to show? Yes, angle AOB is equal to angle DOC. We need to prove this. Now how can we prove this? We need to apply the property of congruence of triangles. See friends, for solving the circles question, your prerequisite knowledge for the triangles means all the properties, the angles and property, the congruence of triangles should be clear. So we can see, first we need to write in triangle AOB, this triangle. In this triangle, OA is equal to OB. Now why are they equal? You can see that this is the center of this circle, which is O, and they are forming two radius, that is radii, and I have told you that two radii are always equal. OA is equal to OB because they are radii. We have these two sides are equal. Now in the question it was given that these two chords are also equal. Chords. So AB is equal to DC, which was given to us. Now we have these sides are also equal. Now now see, yes. Now another property of triangle, that on two opposite but equal lines you have to opposite and equal angles, which means this angle A, this angle and this angle B are equal. I will explain you why they are equal. They are equal because they are the opposite angles on equal sides. See, now we can apply the triangle congruence here. Side angle. On applying the SAS congruence, this triangle and this triangle, triangle DOC is congruent to, this is the sign of congruence, so angle DOC is congruent to angle AOB. Angle AOB. Now what does this triangle congruence means? If two triangles are congruent if two triangles are congruent, then the sides and all the angles are matching. If these two triangles are congruent, then their sides are also equal and all their angles are also equal. So if they are congruent, then it is automatically proved that angle AOB is equal to angle DOC. Angle AOB is equal to angle DOC. Hence proved. Hence our this theorem is proved. Our theorem 2 was this. Equal chords of a circle subtend equal angles at the center of the circle. Our this theorem is now proved. This theorem, the construction for the circle through the help of a triangle, I will be touching in my next live session, and our this theorem 2 is proved. Now we move on to another theorem. Chords of a circle that subtend equal angles and the center are equal. To prove this theorem, it is the same procedure that I listed, that I had shown you. I've just shown you in this part. There is the same theorem. The only difference is that the lines are twisted. Here it is written equal chords of a circle subtend equal angles at the center are equal, and here it is written chords of a circle that subtend equal angles at the center are equal. So the procedure is same because the meaning is same. I had also proved this theorem in my previous live session. Then the next theorem is the line joining the center of a circle and the midpoint of a chord of the circle is perpendicular to the chord. Yes, this is a very important theorem. See, there are total 10 theorems. First, See, I have ticked some theorems with my pencil. Theorem 2, Theorem 3, Theorem 6, Theorem 8 and Theorem 10. I have ticked them because they are the most important theorems and you should know that how to prove them. See, if you know all the theorems, then all the chapter is a cakewalk and there's no big deal in solving the questions with circles. So we have now our next theorem, which is the line joining the center of a circle and the midpoint of a chord of the circle is perpendicular to the chord. Now for this question we ought to draw a circle first. I can solve it here only. And friends, if you need a different detailed video on all the properties of a triangle, like the triangle inequality, the Baudhayana Pythagoras theorem, or these theories, then I will be making a separate live session on them. You can just comment me here or in the comment section. Now to prove the theorem 4, I would be making a circle. See, now in this circle we can see this is the center O and this is our chord. Always name your chords for ease. This is our chord AB. And what does this theorem states? Let us have a look at the theorem again. Theorem 4. The line joining the center of a circle and the midpoint of a chord. It means that now we have to join the center of the circle and the midpoint of the chord. You need to join it with the scale, but as I'm writing with only one hand and with the other hand I'm making the video, so you need to join these 2 points. This should be straight. Then we can form a triangle by joining these 2 other points. Now we have triangle AOB. Now as I listed earlier that whenever you are given a question or a question to prove the theorem, then always you need to mention what is given to you and what you have to show or what you have to prove or what do you have to find. So in this question, given the line joining the center of a circle and the midpoint of a chord is perpendicular to the chord. So it is given to us that this line OM is perpendicular. This is the sign of perpendicular. OM is perpendicular to chord AB. We need to show. Now how can we show this? Just say that these two, OA is equal to OB. OA is equal to OB. Now why are they equal? They are equal because they are the radii. They are infinite radiuses or radii in a circle, and all of them are having the same value. If OA is having 5 centimeter value, then OB will also have 5 centimeter, and the radius of a circle are always equal. You should apply this property in every question. This is very helpful property. O is equal to OB. Now we have 2 triangles, triangle OAM and triangle OMB. Okay, and these 2 lines are also equal. The radius. These 2 sides are also equal, or the radius. And as I mentioned earlier, opposite angles on equal sides are always equal. So these sides are equal. So their angles between them will also be equal. Angle OAM is equal to angle OBM. Reason is a must. You should always mention the reason, otherwise your marks can be cut. There can be loss of your marks. Then opposite angles are equal. Okay, opposite angles are equal. After that, we have this that these 2 radius are equal and these 2 sides are also equal. After that, this point A and B, angle AMB is equal to 180 degree. You have learnt in your earlier classes that a straight line, I am drawing the straight line here, the straight line always forms an angle of 180 degree. Here also we can see that the chord is a straight line, so the chord is forming an angle of 180 degree. So angle AMB is equal to 180 degree. On this straight line we can see two lines, two angles, this angle and this angle. So angle AMO plus angle OMB should be equal to 180 degree. Should be equal to 180 degree. Then after this, what do we need to do is, now just look at the question again. See, the line joining the center of a circle and the midpoint of a chord means it is the midpoint. So we can say that these two lines are also equal. This line AM is equal to angle BM. AM is equal to BM. If you use this property, then it will be a more complex. So just leave this line for now and let us focus on these only. OA is equal to OB because they are radii. Angle OAM is equal to angle OBM. Opposite angles are equal. AM is equal to BM. By using the SAS congruence, side angle side, we have side and we have angle, and we have also one side. We can use the SAS congruence here. On using the SAS congruence, these angles, yes, now these angles are automatically equal. Angle AMO is equal to angle OMB. CPCT. After using any congruence, we can just mention that these two angles or these two sides are equal through CPCT. This is just like a reward we get after proving the congruence. But now, yes, now this line comes. Angle AMO is equal to angle AMO plus angle OMB is equal to 180 degree. Now this line will come here. I am having less space, leave it. Angle AMO plus angle OMB is equal to 180 degree, but these angles are equal, so it is angle AMO is equal to 90 degree and angle OMB is also equal to 90 degree. It is not visible here, I can write it here. Angle AMO is equal to 90 degree and angle OMB is also equal to 90 degree. Let me just clear prerequisite knowledge that whenever a perpendicular bisects the chord, then it always forms an angle of 90 degree, which satisfies our this condition that both the two angles are 90 degree. So hence our theorem 4 is also proved. Now we move on to another theorem. Before this, I would like to tell you that in my channel I have also uploaded a few videos of the derivation of the equations of motion. Like this is the third equation. I have simplified it step by step, like I have told the graph and I have told the derivation process also. So you can check these physics video on my channel. More videos of more subjects like the atom, journey inside the atom, the chemistry, the cell, the fundamental unit of life, biology, and other subjects will also be available soon. So you can just check my live stream, and also you can just subscribe my channel and just click on the bell icon so you are notified whenever a new video drops out. So now we have our another theorem. The perpendicular from the center of a circle to a chord of the circle bisects the chord. See friends, it's the same procedure. It's the same procedure here, nothing is different. It's the same procedure because like the theorem 2 and 3, the theorem 4 and 5, The theorem 4 and 5 also mean the same, just the language is twisted a little bit, but they mean the same only. So there is the same procedure, and the same procedure you will use. We ought to move on the next theorem now. Chords of a circle having the same length are all at the same distance from the center of the circle. So first we need to just make a figure for this. I'm continuing it here. We just need to make a figure for this theorem. I'm using a compass here to prove my theorem 6. Now you can see that I have made this circle. So now for the rest of the part, we need to make a figure first. First, we need to mention what is given to us. Given that the chords are equal, so AB will be equal to DC, because as written in the theorem, chords of a circle having the same length are also or are all at the same distance from the center of the circle. We have that the chords are equal, and we need to prove that the distance between them, that is the distance from this point and this point O, is equal. So what given to us that the chords are equal, and we need to show that ON is equal to OM. So we can use the Bodhayana Pythagoras theorem here. See, let me first clear you what is Bodhayana Pythagoras theorem. And to solve the circles, you should have a prerequisite knowledge of circles. So when you are solving the triangle, you should know that in a triangle, the hypotenuse, this is the longer side is hypotenuse. Hypotenuse is equal to the base square, means this base square plus perpendicular square. We are using the same Bodhayana Pythagoras theorem here. So in triangle OAM, this triangle lies on the chord DC. So in triangle OAM, we have hypotenuse square is equal to base square plus perpendicular square. What is the hypotenuse here? OD. OD square is equal to base. What is the base? DM. DM square plus perpendicular, that is this OM square. Now we can see that as the theorem states that this point, the center point and this chord are bisecting and bisecting at the midpoint of the center. It means that this portion and this portion, that is the line segment DM, is equal to the line segment MC. So we can also write that dm square is the half of DC. OD square half DC. DC is the full chord and DM is the half of it. So full DC, that is the chord square plus OM square. Now on simplifying this bracket, we will get OD square is equal to 1 by 4 DC square plus OM square. This 1 by 4 will get transported here. Okay, OD square as this is in positive right now, so when it will get shifted to the LHS, then it will become negative. Minus 1 by 4 DC square is equal to OM square. This forms our equation 1. We have to do the same for another triangle, but not this one. We have to do the same for another triangle which lies on a different chord. We did for the triangle which lies on this chord. Now we have to do the same procedure for a triangle which lies on this chord. So we can take this triangle, this one. In triangle OAN, hypotenuse square is equal to base square plus perpendicular square. You need to apply the Bodhayana or Pythagoras theorem here. So what is the hypotenuse here? It's OA. And the base is AN. The perpendicular is ON. ON square. AN is the half of the line the chord AB. So AN can also be written as half AB. The whole square plus perpendicular, that is ON square. On simplifying this, OA square will become OA square is equal to 1 by 4 AB square. OA square is equal to 1 by 4 AB square plus ON square, and this 1 by 4 again will get shifted to the LHS, and this is in positive, so when it will get transported here or shifted here into the LHS, it will become negative. So OA square minus 1 by 4 AB square is equal to ON square, and this forms our equation 2. Now what we need to do is, we just need to compare these two equations that we have. OD square minus 1 by 4 DC square is equal to OM square, and OA square minus 1 by 4 AB square is equal to ON square. On comparing, then the RHS, LHS and LHS will be equal. So the RHS and RHS should also be equal. Then we can automatically say that the OM square is equal to ON square. That is OM is equal to ON. We have arrived on this conclusion which we initially needed to show. That is, this theorem is also proved. Theorem 6 is also proved. Chords of a circle having the same length are all at the same distance from the center of the circle. Now let us have a look at the other theorems of this chapter. Chords of a circle that are equidistant from the circle, that are equidistant from the center have equal length. And what was the theorem 6? The next theorem is, the angle subtended by an arc at the center of the circle is double the angle subtended by an arc at any point on the circle outside the arc. This is the most important theorem of this chapter. and I will be touching this theorem in the next video. Let AB and DE be two chords of a circle with center C. Suppose AB is greater than DE. AB is greater than DE means that the chord AB is longer in length than angle DE. Means it means that AB is longer and DE is shorter. Then the distance from C to AB is less than the distance from C to DE. It means that if AB is greater, then the distance from the center is C. Then if AB is greater than the center, distance from center C to AB is less than the distance as compared to the between the center and the chord DE. The next theorem states that angle in a semicircle is a right angle. I can prove this theorem now because this is a very short one. See, according to this theorem, there is a semicircle. The theorem is for the semicircle, but you ought to make a full circle in your exams. But I am making only a semicircle here. So what it states that, let me make a full circle only. This is a rough circle. So what the question states that the center of the circle, the angle in a semicircle is a right angle. It means that this angle should be right angled. Now how to prove it? I have already solved it. Angle in a semicircle is a right angle. To show that angle ACB is equal to 90 degree. To show that angle ACB is equal to 90 degree, either you draw this or there is another diagram which you can draw. I think this one will be the more accurate, so we will cancel this one and we will go on this with this. So what it states that ACB, and this is the center O, that angle A should be equal to 90 degree. Now to show angle A is equal to 90 degree, this angle COB is 180 degree. Why is it 180 degree? Because it is angle on a straight line, so its value will be 180 degree. So it's 180 degree and the angle above it should be double it. Why? First we can mention the statement angle COB is equal to twice the angle CAB. Its reason: angle subtended by an arc at the center is double. The angle subtended by an arc at the center is always double. So we have our this statement. Now as we have already stated that angle COB is equal to 180 degree, so we can replace this angle COB by 180 degree. Angle COB is replaced by 180 degree is equal to 2 angle CAB. This 2 will get shifted here, as this 2 on the RHS side is in multiplication, so it will get divided by 180 here. 180 divided by 2 is equal to angle CAB. Angle CAB is equal to 90 degree. Hence proved. What was our theorem? Our theorem was angle in a semicircle is a right angle. Right angle has the value of 90 degree and we have proved it. So our this theorem is also proved. This theorem is also proved. I am There are other theorems. Theorem 2 and 3 mean the same. 4 and 5 also mean the same. Theorem 6 I have discussed. And there is one more property. It's not a theorem, but it's just like a question. The question is, that if the perpendicular distance of a chord from the center is d and the radius is r, then the chord length is this much. We will also be touching about this question in the next video. Till then, I will be solving and proving the other theorems in the next video. So till then, hope you enjoy. Thank you for watching.